Okay, so title of this presentation is called How to Accelerate Your Startup by Avoiding Technical Debt. So let's start with something depressing, because everybody likes that. So the current statistic right now is that 68% of software projects fail. And like, that's obviously a very big number. So the question you might ask is why? Why is that number so high? Why are 68% of software projects failing? And the reason is this thing called technical debt. And unfortunately, this is something that doesn't really get talked about very much. So basically, technical debt is just a way of referring to code in a program that is not very well thought out, right? But unfortunately, that's not a very saleable thing, right? You can imagine the conversation, right, with the technical guy and the business guy, and the technical guy says to the business guy, we need to rebuild this code. And the business guy says, well, why? And the technical guy says, well, because it's not well thought out. It's crappy code, it's bad code. Business guy says, well, are there bugs? Well, no. Are there security issues? Well, no. Are there performance issues? Is it going fast? No, not. It's all good. Well, then I don't care about this bad code thing. I don't care what you smell. Just keep going. We got to ship. We got customers to deliver to. And this made technical people very frustrated because we had no way to sort of communicate the business cost of bad code to the people who weren't developers. So we came up with this term called technical debt. Because it's something that sort of everybody can understand. So the idea behind technical debt, it's kind of like, technical debt is kind of like financial debt. So if you think about financial debt, you go to the bank, you take out a loan. For the term that you have that you're drawn on that loan, you're required to pay an interest cost while you are, you have that loan in your possession. Technical debt is, well, so bad code, technical debt, kind of the same thing. It's kind of like that. For the length of time that you have this poorly thought out code in your project, it doesn't incur like a monetary interest cost, but it actually incurs like a development speed interest cost, right? So if you have monkey patch something, you make a mess, it slows you down a little bit, right? And then you make another little mess somewhere else, and it slows you down a little bit. And just like there is financial debt and financial bankruptcy, there is also technical debt and technical bankruptcy. And sorry, I should switch the slide there. But okay, so technical bankruptcy. So this is a pretty bad place to be. If you could take a look at a wiring diagram, it's not wiring, it's software, right? But if you could sort of project the concept of technical bankruptcy into a wiring diagram, it would probably look something like that. And this is a pretty scary place to be, because you could actually look at this and say, it's entirely possible that this system has no bugs in it. It's possible. It's entirely possible that this system is running at optimal performance, right? It's entirely possible that there's no security issues here, right? But that doesn't mean that this is an absolute mess, right? The problem here, well, first of all, you're going to have absolutely no hope of hiring any kind of developer or technical talent at all, because nobody's going to be wanting to be knee-deep in crap in their job. That's the first problem. But the bigger problem is that with an architecture like this, I use the word architecture very liberally, but with an architecture like this, you're in a very scary position because you're unable to respond to the changes to the market, right? And I'll get to that in a second. So, question is this just me FUDing it or whatnot, or is this actually a real problem? So, I said that 68% of software projects fail. By far the biggest reason that they fail is this thing called technical debt. But there's also a lot of companies that are financially successful that are also swimming in technical debt just because the business that they're in. So to give you a concrete example of a company that you're all familiar with that had problems with this, this is a stock chart of Apple versus RIM. Now, Balsillie and Lazaridis, when they were going through all these issues, they really got blamed for, oh, you guys are, not in touch with the market, and you don't know what people want, and what's wrong with you? Why don't you just stick a camera on the phone because that's what people want? I mean, these guys aren't stupid, right? Like they knew what the people wanted, but unfortunately, when your architecture looks like this, and your competitor looks like that, this is game over. There's no possible way you can compete with this. So next point I want to make is that the technical debt of a code base and the failure of a company never seems to be blamed on technical debt. It's always blamed on something else. So in RIM's case, it was, oh, you guys are out of touch with the market. In the startup case, the reason for failure always tends to be something like, oh, we didn't close our funding in time, or the investor screwed us. But the reality is, in that startup case, it's if you hadn't have had this, then you probably wouldn't have needed that second piece of funding. And in the RIM case, if you hadn't have, to give you a quick story here, I mean, I don't have firsthand experience with this. I've heard this from a number of people, and maybe some people in the room, if you have experience with RIM, have heard this story. But one of their strategies when they were shipping a version of their operating system was, this is not a lie, they had, I think, 25 different versions of their operating system, and the strategy was to ship the one that crashes the least. I am not kidding. That is 100% true. I don't know about the 25, but it was over 15 anyway. And so, I mean, that's this, right? And when Apple comes in and they look like this, like I said, it's game over. There's no possible way you can compete with that. So next point I want to make is that technical debt, just like financial debt, it's not always bad, right? There is a time and a place to use it. So for example, I mean, the good times to use financial debt, get a loan at the bank for a good reason. But there's good reason to use technical debt. So for example, if you are trying to, let's say you have a big customer, and the customer has certain requirements for your product, and they need to ship, they need to deliver to this customer within 2 weeks. But your problem is you've got a month of development work to do. So what do? I mean, you're not going to lose the customer, right? So what you end up doing is you end up kind of making a mess, start monkey patching things, kind of get this thing sort of hobbled together and say, all right, it's working now. And then after you've shipped and you've closed the sale and you've made the customer happy, after that you need to go back and pay off that debt by cleaning up the code. And if you don't do that, then you just keep on incurring more and more technical debt to the point where you end up with technical bankruptcy. So you see a lot of people who aren't developers saying, oh, cleaning up code is a waste of time and whatnot. Cleaning up code is not a waste of time. That can actually be the difference between success and failure, as I explained. But now, there is a slight problem here. And the problem is that the biggest reason for technical debt accumulating is not because of time constraints. Sometimes it is, most of the time it isn't. Most of the time it's because of, for lack of a better word, I mean, it's sheer incompetence, right? And I mean, competence might be a bit of a strong way of putting it, but creating an architecture that is very complex and everything is well structured, that's very hard, right? That's not, I mean, you can't just wake up one day and decide you're going to be a developer and get to that point. And the reason is because it takes a lot of years to understand how your technical decisions are going to have, like, it takes many years to understand how those decisions are going to play out in the future, right? So understanding the long-term consequences. And you have to do a lot of experimentation. You have to get burned a lot of times to know, oh, this doesn't work, oh, this does work. You got to be playing around with all different ways of doing things so that you can sort of piece things together. And that, you can't be programming for a year and expect to be able to do that. It's unreasonable to think that. So, and because of that, you end up creating these solutions that are suboptimal, and then you end up with technical debt, and then you have the problems that I called out earlier. So I have a solution here, and I think as Joy called out, it's to do with the company that I'm that I'm representing. But before I sort of get into sort of how I fix this and how I'm trying to address this, I need to diverge a little bit and just kind of explain a couple things about sort of the history of software architecture to make sure this is understood. So there's this, applications have this thing, front end and back end code. And you've probably, if you've been around developers, you probably have heard this before. But it's not entirely clear what front-end code actually is and what back-end code actually is. And even to developers, sometimes they're even confused. And this makes sense. And the reason why there's confusion here is because the architectural styles that we've seen over the years have been mutating quite a bit. So there's sort of changes happening. So we don't really know. It was hard to describe sometimes what actually is front-end, what actually is back-end code. So if we rewind a little bit, this is the Web 1.0 model, mid to late 90s, early 2000s. We now refer to this architectural style as server-generated templates. And basically how this works is, let's say you got a website. You can see I got my Internet Explorer 6 there from 1998. How this works is, let's say you've got, I don't know, Kijiji or something. So you go to Kijiji, you type in kijiji.ca, and then you press enter. Kijiji website would come down to you. And now let's say you want to look for couch. So you type in couch, press enter. Couch would then move off. That word would go to the server. Then the server would have to take that couch word, then it would have to run a bunch of database queries to figure out, what are the couch listings that are available at the current time. Possibly maybe there's some security stuff that maybe you're not looking for couches, there would be security, but a whole bunch of things that it needs to do. And then it generates this HTML page, so a front end. And then once that HTML page is generated, it sends that back to the browser, and the browser renders it. So with that architectural style, it's kind of difficult to maybe understand where the front end is, where's the back end. I mean, is the front end over here on the server? I mean, that's kind of, it's generating the front end. Is that the front end code? Is it over on the browser? I mean, that's where the front end is. So you can see there's confusion there. You don't really know what front end code and back end code is. And that architectural style led to some problems where, I mean, if you remember the old web, whenever you would do anything, you have to get a page reload, you want to run a query, and then another page reload. Really drastically, negatively affected the user experience of the site. But beyond that, it created architectural problems because you're trying to make things do stuff that it wasn't really meant to do. So you had some issues there. So because of that, that's why we moved to the Web 2.0 model. This is, you're looking at like mid to late 2000s time. And the idea here, we call this the API server model now. The idea here is that we recognize that with the old model, you had you sort of had two pieces. You kind of had the user interface, and you kind of had like the data part, and they were kind of jammed into one. So we said, okay, well, these are kind of separate things that don't really have much to do with each other, so why don't we split them apart and put them in the locations where they make sense? So now, the front end piece, the HTML, that's served from a content delivery network. If you're not familiar with what a content delivery network is, it's basically a network of servers that are geographically distributed across the world, and it's highly available. So if one of them blows up, then it just kind of goes to the next one. They're designed really well for just serving out HTML, JavaScript, static assets. So the static assets come down from the content delivery network. They go down to the web browser, and now your server doesn't have to be dealing with generating all that HTML and stuff. Now it's basically just sending back requests, right? So you go to Kijiji, you type in couch. Now the couch word goes off to the server. The server says, oh, you're looking for a couch. And then it just generates, not the whole website now. Now it's just generating a little bit of data, shooting that data back to the browser. And now the browser can just take that data, and because it's a smart front end, it's not like a dumb front end, it's smart enough to take that data and use it to render the new listings. So that's why, I mean, this architectural style launched sort of the Web 2.0, which was, a lot more interactive websites. You're able to do things without reloading the page, so improve the user experience, also improves the things from an architectural perspective. Now, current model. Right now, we're still kind of on this model, on the Web 2.0 model, but it's evolved a little bit. So the evolution that we've seen is, I mean, you still have the content delivery network. I don't have it in the slide here because it's not important. But essentially, what we have now is you have this server, and what we noticed is that a lot of the things that these servers were doing was the same stuff over and over and over again for every project, right? So Kijiji, for example, I mean, they have to send emails. And a lot of people have to send emails. They have to charge credit cards because you can get those premium listing things. I'm sure they're doing image moderation. And a lot of startups and software projects need all these things. So we have these services now, microservices is what we call them, where instead of having to build the email sending infrastructure yourself, you would just take that from the server and move it off into these third-party services that would just provide that for you automatically, so that you would only have to really build the part that serves your data. So that's kind of where we are now. Is everybody kind of on the same page? Everybody's muy bien? Okay. Okay, so I'm going to get back into technical debt, but I need to talk about one more thing now. So, complexity. So, if you kind of simplify that diagram even more, you kind of have the two pieces, right? You kind of have the back end piece, which is kind of the data service, and you have the front end. Now, if you look at sort of the size of these two graphics here on this slide, they're about the same. And that is relative to the amount of work that you're going to put in bringing a prototype or an MVP to market, right? The back end is usually about half. The front end is usually about another half. I mean, it could obviously be different depending on the project, but generally speaking, that's about where it is. Now, when your project matures and you start adding users, start adding scale, it starts to look a little more like this. The back end absolutely dwarfs the front end. And to give you an understanding of why this happens, think of it as the difference between hosting a Super Bowl party with your friends and family and hosting the actual Super Bowl, right? It's totally different. There's totally different things that you need to deal with just with dealing with that much scale. So this is what it looks like when you start getting to the scale level. Now, just by virtue of the back end being that much bigger, being that much more code in the back end than the front end, you can probably figure out where the technical debt is happening, right? I mean, even with an even distribution, you're going to have 90% of your technical debt happening here, and then only 10% happening on the front end. But it's actually even worse than that, and the reason is because back end code is there's a lot more opportunities to screw up with back end code. Just sort of the nature of how it works. You need to deal with keeping them alive. You need to deal with security and Chinese hackers coming in and stealing your server. That happened to me once. So there's all these databases you got to pick and all these opportunities to do things wrong. So it's fair to say that the vast majority of these technical debt issues are happening on the back end, and my personal experience also confirms that. So the solution that I have kind of involves taking this sort of microservices architecture where we have this server with pieces that were pulled apart into separate services that are provided by third parties. If you take that, you could just kind of bend your mind for a little bit and think, well, why can't the actual data just be a microservice, right? And when you do that, when you take that approach, you end up with a very different architecture, because now you're not actually building anything in the back end. You're basically only just building a front end, and then the front end just contacts your data service directly to say, send me all the list of couches, and then you get back the data for the list of couches. You're not building custom logic in your server to send back specific search queries, right? All that stuff is just, it's a service, so it's already built for you. And then you're able to just, of course, contact the server to send the emails, to charge the credit cards. There's a security layer there if you do this properly, moderate images. So you're able to chop out a vast, libelous portion of the the thing that you're gonna build. So, benefits of this architecture: obviously, less risk of technical debt because you're not building the piece where where the technical debt tends to hang out. Obviously, if you are not building a back end, which is 50% of the code for your project, you're going to get to market twice as fast. And then, of course, the cost is going to be half as much. But then the biggest thing is as you start growing, you're going to see a massive reduction in the cost and the massive increase in the development velocity of your project, because instead of, when you have a website and you want to add a new, or that's not your website, it could be a mobile app or whatever it is. When you want to add a new feature anywhere, there always has to be back-end support for that feature. You can't just add it to the user interface. I mean, what's it going to go to, right? And there has to be something backing it, right? But when you have a serverless architecture and there's a system in place where it can just do anything that the front end wants, then every time you want to add a feature, you don't need to, of course, you don't need to also add that functionality to the back end as well. So let's talk providers. Where can you actually go to get one of these back end as a service things? The most popular one is called Firebase. They're actually a pretty good product. They are backed by Google. I've got quite a bit of experience with their product. I worked with it for a year or two. Like I said, really good product. Problem is, it is built for very simple use cases. So the second your project has any kind of complexity at all, the service tends to snap like a twig. And I resisted that because I was working on a previous thing before I was working on what I'm doing now, and I tried to avoid having to build a server like the plague. I was in love with the serverless architecture. And I really, really, really tried hard to like Firebase, and it didn't work. So, ironically, when the thing that I was working on before I was doing this kind of faded off into the distance, I decided that, well, there's a market opportunity here, and I should probably build something that is, kind of has sort of some of the Firebase ideals, but is capable of supporting more complex projects. So that's why I have Back.io. The name of my company is Back.io, and Back.io is just that. It's a back-end as a service like Firebase, except you're able to build, basically anything that you could build with the serverless architecture. You're not just limited to very, very simple use cases like Firebase. So speaking about use cases, let's talk about some use cases. Everybody likes use cases. So on the left side there, you get the green. So I mean, basically anything where you are pulling down data, moving data to another location. We call this transactional data. That's sort of the technical term. So Airbnb, any type of marketplace would work with a serverless architecture. Reddit, so any type of user-generated content thing would be a good fit. E-commerce stuff, I mean, if you're actually just building a simple e-commerce platform, probably Magento or Shopify is a better solution for you. But if you're doing something custom, then you can absolutely build that with a serverless architecture. Trello, any kind of project management stuff. Again, it's just sort of moving data around from A to B. Snapchat, again, mobile app for sending messages back and forth, would be a good fit for a serverless architecture. So on the bad side, the places where this might not be a good fit, and I don't think there would be anybody in this room who would be doing something like this, but I see a lot of people these days, especially with this whole big data thing being super popular. If the use case for your software is, I don't know, doing something like pulling in a whole bunch of Twitter feeds from somewhere and then doing data mining on these Twitter feeds to try to understand it, then a serverless architecture probably isn't the best choice. And that is pretty much it. So I guess we have a little bit of time for questions here. Back.io right now is in a state where we are looking for people. We're looking for people that want to build projects on it. So I mean, if anybody here wants to take it for a spin, I'm not looking to make any money or anything. If you want to sort of, if you got a project in the cooker that you want to put together, I'd be happy to talk to anybody if that's what you're interested in. So yeah, that's it for me. I'll take some questions.